We are AGH Space Systems team from Krakow, Poland, consisting of over 20 members with broad engineering and scientific backgrounds. Today we present to you Kalman, the rover we have been working on for the last 1.5 years.
The suspension is a simplified 4-wheel rocker buggy design made of aluminum alloys and steel. Each of the rover's wheels is able to turn independently, allowing for agile and precise traversal. The main drive motors are hidden inside the wheels, which protects them from the damage when moving through rough terrain. We make extensive use of 3D printing technology. The tires are fully printed out of elastic material. The hexagonal internal structure allowed us to create a tire that has all the properties needed in the desert. Electronic cases are also printed to reduce weight. The manipulator has a 5 degrees of freedom structure, with 2 of the most loaded joints driven by linear electric actuators, providing satisfactory stiffness even at loads up to 5 kilograms. Every joint position is monitored by potentiometers and controlled using inverse kinematics. All the cabling is done through connectors, and the manipulators can easily be removed for the time it's not in use. Parts exposed to high levels of stress were checked using FEM methods to ensure their durability.
The whole electronic system was designed from scratch, based on STM32 architecture and CAN bus, a proven and reliable solution used in automotive industry. Its modular structure allows for parallel development as well as easy expansion with additional subsystems. Every module is carefully protected against overloading, voltage spikes and overheating. The master module is responsible for communication between the main computer and the controller network. 2 most crucial modules during the mission, drive motor and arm controllers, are also redundantly connected by RS485 bus, in the unlikely event of CAN bus failure. The individual functionality blocks, such as motor controllers, are unified for the sake of easy development and repairs. The communication between our rover and ground station is provided using 868 MHz radio. Camera feed is done using 5.8 GHz analog transmission.
Development of a self-sufficient navigation system takes time. That is why we have created a simulation providing all sensory data and allowing us to develop the autonomous control software while the rover's construction was still in its early stages. A hardware-in-the-loop simulation gave us insight into final system performance. The NVIDIA Jetson TX1 and TK1 provide more than sufficient computing power to process all of the sensory data. Using the onboard GPUs, we have built a powerful genetic pathfinding algorithm able to guide the rover through difficult terrain based on a map created using LiDAR technology. The GPUs also power stereo vision, one of the most accurate data sources we use for odometry. All that in real time. Ground station software is crucial for communicating with the rover and remote control. Each of the application's layouts was tailored to fit specific needs of team members, allowing the operators to focus completely on the task at hand.
A rover's onboard laboratory is fitted with sensors which measure soil humidity and temperature, as well as carbon monoxide and methane concentration. The drill module is able to reach depth of 20 cm, collecting sample from a desired range, moving material into a sealable container. Then a probe is lowered into the hole, providing information about the site. A custom spectrometer allows us to determine main soluble chemical components of the sample. Strip and drop test kits as well as electronic sensors give us quantitative analysis of the solution. We use the microscope and simple reagents to analyze the insoluble part of the sample. Our main method of live detection is the use of acridine orange, which merged with RNA and DNA illuminates with certain colors when put under UV light. We can see that using a high magnification microscope. We also use ninhydrin to detect the presence of amino acids.
This project is possible thanks to huge support from our university, the Ministry of Higher Education and private sponsors. The team has already secured all the funds needed to participate in the finals. We strongly believe that we are ready to compete with the best teams on the Mars Desert Research Station.